Meet the lathe. This lathe is one of the several machines that came from my grandfather's shop. It's an older manual style lathe from the early 90s. Over the years I grew up using a lot of different machines, but this one became my favorite for many reasons. For one, I just love the way it looks. It's like a big dense block of mechanical precision. The knobs and dials and hand wheels are all perfectly shaped and located for operator ergonomics. And because this is a fully analog machine, everything is out in the open, meaning you can actually see all of the individual functions, which I like better than modern CNC machines that are just fully enclosed boxes hiding everything. The only downside to this machine being fully exposed is that it makes quite a mess. Metal chips, oil, and coolant tend to get everywhere. And after sitting unattended for a few years, this machine looks pretty rough. So let's get it cleaned up. My grandfather was a pretty smart man, and in his infinite wisdom he had the forethought to put this 4,000-pound machine on wheels, as well as all the other heavy items in this shop. So in a matter of minutes I'm able to move everything out of the way and get the lathe out in the open. For as large and unwieldy as this machine is, those pivoting casters on the one end make it not so bad to move. Now I can start cleaning. Fortunately, most of the surfaces are painted, so the rust isn't bad. Not so fortunately, there are a lot of surfaces. Much like on the mill cleanup, all the grease and dust and chips doesn't really hurt anything. But like I said, this is my favorite machine, so I want it looking spiffy. This end of the machine with all the knobs and levers is actually two gearboxes stacked on top of each other. The top one is called a headstock, and it houses a spindle that a chuck can be mounted to hold your part. This spindle has 8 gears ranging from 76 RPM to 2000 RPM, and they are changed using these two levers. The second gearbox is kind of this middle section here and is for controlling the feeds and threading features. As you can see, there are a lot more knobs and levers here, with a lot more settings. I'll play around with these more once I get the rest of the grime off. Moving on to the backsplash and containment tray, it's pretty obvious this is where all the mess went. I guess that's to be expected, given their names. While I can clean a lot of the surfaces while they're still mounted to the lathe, a lot of the areas are straight up inaccessible. Off they come. On the floor I can really put some muscle into scrubbing and see how gross they actually are. Cleaned up, there are some flakes in the paint, but I think I can live with this. It won't be long before these are a mess again anyway. The chip sludge also made a pretty big mess on the metal casting under the chuck. This metal casting is actually one single piece making up a large portion of the gearbox and extending all the way to the opposite end of the lathe. The top surface of this hunk of iron has perfectly smooth ways ground on it. The rest, on the other hand, is not perfect and definitely not smooth, which makes it a bear to clean. Many times I had the urge to bust out a die grinder and go to town on some of these bumps and whatnot, but my judgment got the better of me. These are not super visible areas to begin with and will also be a mess again before too long. Cleaning in and around all these tight areas was a bit tedious, but I gotta say the payoff was worth it. This is already starting to look like a different machine. Honestly, I've never seen it looking this good. Now, not only do I love this machine because it looks cool, but it also sounds pretty badass as well. When this thing turns on, it sounds like Optimus Prime booting up. Way more industrial sounding than you would think from this small machine. While the lathe obviously does turn on, there are a few other electrical features I want to confirm are working properly. To start, I'm looking at the source of all the controls, the main electrical panel. I just need a key. Should be around here somewhere. If only I could find it. Almost as if the designers of this lathe anticipated this problem, they put an override screw in the door. Thanks, guys. Oof, That's not super encouraging. Looks like some mice have been having a little party in here. Vacuumed up though, this doesn't look so bad. No chewed wires, no loose connections. This is honestly a miracle. Even though this looks good, there are a few other electrical features on this lathe I want to check out. First is the drive system door switch. This is a redundant safety preventing the motor from turning on if I have this cover open. That would be really bad for my fingers, so I'm glad the lathe has my back. Next is the emergency brake. This red foot pedal on the front of the lathe should actuate a mechanical brake on the main motor shaft. It should also trigger a limit switch that cuts power to the motor. Just like that. Alright, with the safeties working perfectly, let's move on to the light. The bulb was busted, so I swapped it with a new one, but I still don't seem to have power here. Yes, it's plugged in. After busting out the multimeter and spending an hour troubleshooting, I found out that the light works just fine. It's my brain that's faulty. Note to self, 110 volt bulbs don't work in 24 volt sockets. I suppose I should have checked the electrical diagram first. I do have one problem that definitely does exist though, and that's the coolant pump. This one doesn't seem to turn on. But since I don't intend to use it anytime soon due to the small scale of work I'll be doing, I think I'll just kick this can down the road a bit. Now just because the safety features are working properly, this can still be a very dangerous tool to use. In fact, that is actually another one of the reasons it appeals to me. There's an inherent element of risk in using a lathe, but it's a risk that can be mitigated by proper techniques, setup, and focus, all of which are 100% in my control. The chuck of the lathe probably poses the biggest element of risk. If it's not spinning really fast, it's spinning with a lot of torque and is basically unstoppable. For the sake of the queasy, I won't elaborate, but you get the idea. This particular chuck is called a 3-jaw for obvious reasons, but it has seen better days. It's covered in rust and also seems to be a bit gummed up inside. So let's take it apart. With everything apart, I can see why this chuck was hard to use. The old oil in here seems to have partially solidified into a sticky, gooey substance. Cleaning this up is a perfect job for the parts washer. The solvent worked through the former oil with ease and even got a head start on the surface rust. But there is definitely more rust here to remove. Since I'm feeling a little frisky, I'm foregoing the rust converter for some old-fashioned elbow grease. Scotch-Brite pads and penetrating oil actually made pretty quick work of the surface rust. To lube all these gears and whatnot, they do make a chuck grease, but I didn't have the forethought to order any. So instead I'm using motorcycle chain lube. By my thinking, if it's tacky enough to stay on a whirling chain, it should work well not to fling off of this chuck at speed. Back on the lathe, this chuck looks great and cleaned up way better than I was expecting. Now because this is a fully manual machine, the parts made on it are a direct result of my human inputs, which is a challenge I really enjoy. The operator inputs on this and most other lathes are done through the carriage, cross-slide, and compound rest. Each of these are controlled by hand wheels that move the components along precision ground ways. The largest of these ways are the ones for the carriage, and these actually make up the Z-axis, not the Y like you might think. I actually only recently learned this little tidbit from a viewer, so if you're watching this, thank you. Because these carriageways are fully exposed along the length of the machine, they're relatively easy to clean. Some mild scouring with a Scotch-Brite pad and a few light passes with a whetstone to smooth out any nicks, and they're looking good as new. The cross-slide and compound rest, on the other hand, will need some disassembly to get at the ways. But while this is still mounted here, I'm going to go to town on this rust. That looks great. Even matches the sheen of the chuck. Easing the cross-slide assembly off the carriage reveals some bad news though. There isn't any damage, but that oil definitely shouldn't be black like that. I'm pretty sure this hand pump should be pushing oil to these ports, but I'm getting nothing. I'm also not feeling much resistance in the pump. Let's see what's going on. This is a good excuse to drain the carriage oil and refresh it anyway. With just a few screws, I pulled the hand pump off the side here and actually discovered it has 2 plungers. The second one seems to be actuated by a cam on the carriage hand wheel, so it works sort of automatically. No problems that I can see here. Must be something inside the carriage. I removed the oil pickup assembly and spotted a potential problem. There was a check valve inside this elbow fitting, and it was completely locked up. Got it cleaned up so we can put this back together and see if that fixes the issue. Still nothing. I can hear the check valve ticking and feel a little more resistance. Oh, and oil is coming out on this way, but not the others. The only other place I can really access is this distribution block from under the carriage, and it was definitely gummed up with old oil, as were the ports leading to the ways. With some thin wire, brake cleaner, and compressed air, I think I have these cleaned. Moment of truth. Attaboy. With that issue resolved, I can slip the cross slide back on and install the gib. The gib is basically a shim and lets me adjust the play between the ways. I only want this tight enough to remove the free play but still be able to move the hand wheel with ease. The compound rest is a similar story. Clean it, lubricate it, install it, and adjust the gib. The last piece of this stack is the quick change tool post. This is the part that actually holds the cutting tools. And it's called quick change because, well, you can change the tools quickly. One final thing to take care of up here is the tailstock. The tailstock can hold various tools like chucks for drilling holes or centers for supporting long workpieces. One thing I do want to check is that it's centered with the spindle. Mounting a dial indicator in the chuck, I can sweep through the inner mounting bore of the tailstock to get an idea of how far off center I am. Looks like it's too far to the side by a few thousandths as well as too high. I can adjust the side-to-side position with these 2 adjusting screws. The height on the other hand is a trickier problem to solve. Since there's no vertical adjustment, it looks like I'll have to either grind or mill the height at this interface. Sounds like a problem for another day. The last bit to clean up on this machine is the carriage, feed rod, and lead screw. The carriage houses the hand wheels for the X and Z axes as well as levers for engaging the feeding and threading features.
Easy muscles.
There are a lot of really tight areas covered in a film of grease and oil. Fortunately, this film protected everything from rust, so it was just a matter of getting in there with some small brushes to get everything looking new again. That looks so much better. The feed rod and lead screw were also almost completely rust-free, and basically just needed a good wipe down and re-oil. That just leaves one last surface to clean. And I'm done. Everything is finally clean. I've mentioned this lathe has some pretty cool power feeding and threading features, so let's take a look at these. Both of these features move the carriage of the lathe to perform cuts automatically. The power feed moves the carriage through a drive connected to the rotating feed rod. And threading moves the carriage by engaging with a rotating lead screw. All of the feed rate settings are laid out on these 2 charts. Most of the settings can be selected with these 3 levers, but there's one setting that takes a little bit more effort. The change gears. This lathe came with a whole set. Oh hey, the electrical panel keys. I knew I'd find them eventually. The change gears are located behind the pulley cover and have to be physically swapped out for other gear combinations depending on what setting you need. Once the gear combination is swapped, it's helpful to mark the chart so you don't have to take this apart to remember what combination is in here. Ask me how I know. Alright, time to chuck up some metal and make some chips. First, let's do some cleanup passes with the power feed. This is another reason I love this machine so much. Watching the smooth and consistent removal of metal is almost hypnotizing. Though that smoke from the cutting fluid is a bit concerning. I don't think it's supposed to be doing that. If anyone has cutting fluid recommendation, let me know. Now I want to make some threads. I want a pitch of 10 threads per inch, so with the machine off I can adjust the gearbox levers according to the chart. On the carriage I engage the thread dial with the lead screw. Since cutting a thread will take multiple passes, this dial helps me make sure I start the thread feed at the exact right time, so each pass lines up with the previous one. With everything set up and the lathe spindle at its lowest speed, I'm ready to cut. When the O mark on the dial comes around, I engage the thread feed with this lever. And we're cutting. Watching that tool line up perfectly with the groove is so satisfying. After a few more cleanup passes and a parting cut, I have a finished part. I'm not super impressed with the finish here, so I'll have to see what's going on. Regardless, this part will work just fine as a rest pin for the hydraulic press. So there you have it. After 2 weeks of cleanup, this lathe hasn't looked this good since it came from the factory. Without the grease, dirt, and grime, you can really see the beauty underneath. It's going to be such a pleasure making parts on it again, and I have a few things in mind. So let's get to work.